This is on completing the square. This is a review of an Algebra 1 topic, but we'll be needing it in geometry to help us with our equations of circles. So you should have gotten a handout like this. If you don't have one, you should get it from the classroom or from the website. We're going to want to make perfect squares. And let's review how we do that. Okay, first off, let's remind ourselves what happens when you multiply out some things. So let's say I have x plus 3 quantity squared. First off, we're going to remember that no way is that x squared plus 3 squared. Some of y'all are still making that silly mistake, so it was like time to quit doing that. Okay. X plus 3, the whole thing is the base of the exponent. You recall with the base, you're to write the base the same number of times as the exponent. So I'll write x plus 3, the base, 2 times the exponent. Then I'm going to multiply it out, 3x. And 3 times 3 is 9. Whenever you have a perfect square like this, the two terms, the middle, will automatically be identical. We can put them together, and we can talk about it as 2 times 3x. Or we can say, of course, 3x plus 3x. But one way to see the pattern, which we also talked about in Algebra 1, was it's 2 times 3x. Because 3x, look at what you get here. Obviously, that's going to be 6x when you add it or when you multiply it. Our final is going to look like this. Look at the similarities here. In our original perfect square, the first term in the parentheses was x. The first term in our expanded version is the first term squared, x squared. The last term, 9, is the last term in the parentheses of the factor squared, or 9. 3 squared is 9. The middle term, if all I knew was 6x, and I knew it was a perfect square, then I would know that it came 2 times the middle term when I multiplied it out to make the one middle term together, 2 times the individual ones. So, to find out that it had been 3x, I can just take half of 6, and I know that it was a 3. That gets me back to what was the coefficient in each of these, and in this case, what was the original coefficient there? I mean, the original number there. So what am I going to do then? Well, I'm working backwards, so it's going to be kind of like dividing. Here I multiplied by 2 to get to there. Now I'm going to divide by 2 to get back up to where I need to be. So I take 6 divided by 2, and it tells me that it's going to be a 3 in there, just like it was a 3 and a 3 here. Okay? This works, of course, when there's no coefficient other than 1 with the x term, and we will assume that, which I'll talk about here when we do our completing the square. Okay, I'm going to give you a brief overview and run through a problem here with regard to completing the square. So let's look at how this goes. Okay. Some of the things that we need to notice here. We're going to have an equation. The coefficient of x squared term of the quadratic term needs to be 1. If it's not, divide so that it is. We'll then rearrange the equation so that the constant terms are isolated and simplified on one side of the equation. Well, do we need to do that here? First off, this one is already 1, so I don't need to divide by anything. But if it were not 1, I'd want to divide by the coefficient so that to make the coefficient here 1. Sometimes that'll make it more problematic for completing the square. A lot of people use this completing the square, find it simpler than many of the other ways to solve quadratics. It can become more complicated like any one of them, but for now we're learning to do completing the square so that we can use it in the formulas for the equations for circles. Okay, this one is already 1, but there's this errant 4 here. It must be banished out of the land of the x's and go to the other side. Oh, what do I do? Plus 4. There we go. So what's left here then is x squared plus 10x equals 9. I've banished it. On the left side, or at least on one side, are all the terms that include any kind of variable, and their like terms are combined. On the other side is only constants, solo constants, and any like terms are combined. All the terms are combined. Okay, so now then, I've noticed that the coefficient is 1, and I've rearranged it so that the constant is isolated. I'm going to tell you here, helpful hint, hopefully helpful, always put a plus blank on both sides. I know you're going to say it's too easy, I don't need to do that, but this is what people forget. They forget to put the 1 over here. So make yourself do it at least for a long while. Now, I'm going to walk through it here. Here I've already got it printed out as x squared plus 10x plus blank equals 9 plus blank. So what's the thought process we go through here to do this? Let's look at it. We'll say, okay, x squared plus, okay, 10x. I want this to be a perfect square because I want to be able to have a perfect square, and I don't care what numbers are over here. This is a perfect square. All I've got to do is square root both sides, and I'm done. Because over here, it's just numbers. I'm just going to square root it. But if I can make this side a perfect square, life got a lot easier for a lot of things. Okay, we recall that if this is going to be my middle term of a perfect square, then it had to come from half of that number. Half of 10 is 5. So the 5 will be the number in my factor. I take the 5 and square it, 25, to make my perfect square trinomial. So x plus 5 quantity squared equals x squared plus 10x plus 25. The plus 25 has to be here, or it doesn't equal x plus 5 quantity squared. When I expand this out, multiply it out, this is what I get. But wait, I must add the same thing to both sides of the equation. I added 25 to the left. I must also add 25 to the right to keep them equal. Otherwise, they're not equal anymore. So what I have my factored form of my perfect square, x plus 5 quantity squared, and I have 9 plus 25 is 34. I have now completed the square. I'm going to solve it. I'll take the square root of both sides. Having the square root of both sides, okay, well, the square root of it squared is just back to what it was initially. So this is x plus 5, no squared. I'm good, it's easy. A reminder, when you put the square root sign in, you have to put a plus or a minus in front of it. If it was given to you, then you take it as it's given to you. But if you're the one that puts it in, you're going to have to put in the plus or the minus. When I solve for x, then this will be x equals negative 5 plus or minus the square root of 34. This is a perfectly acceptable answer depending upon how you were asked to do it. If you were asked for a decimal answer, please remember that you're going to have to do this twice in your calculator. Negative 5 plus the square root of 34 will be one answer, and negative 5 minus the square root of 34 will be your answer. It's a quadratic. It has two answers. Okay. The fancy way to write this up on completing the square looks like this. So you might want to make a note of this. You probably had something that looked a little bit like this last year. But there's the official fancy way to write it out, which you might as well know. And here endeth the lesson.